This question is an Ohm's law electrical or electronics question, where it says a resistance of 2 ohms is connected across a 10 volt supply. So there's a 10 volt supply, the other end is connected to ground, and there's a resistor connected. This is in series, so it's across the voltage supply. And the question will then say a voltmeter has been attached in the correct way. And when you attach a voltmeter, the 2 cables go across the thing that you're trying to measure the voltage of. When you measure currents, ammeters go in series, but voltmeters measure a potential difference. And to get a difference, you need to measure 2 different points. So this voltmeter has been correctly attached, and it tells us the internal resistance of the voltmeter is 3000 ohms. Now in real life, voltmeters' internal resistances are so high that they don't change the circuit, but this one does because it's not a very good voltmeter. But it says the internal resistance of the meter, which I've called Rm for the resistance of the meter, is 3 kilo ohms or 3000 ohms. And it'll ask you, when you've put the voltmeter in the circuit to measure the voltage between this point and this point, remember this resistance is just the internal resistance that the voltmeter has. It says how will the current change? So firstly, we need to figure out what the current is in the first place without the voltmeter. So without the voltmeter, what is the current? Well, from Ohm's law, remember Ohm's law is V equals I times R. So that gives us the current I equals V divided by R. Because you move the R across, swap and drop, and I becomes V over R. So the current before the voltmeter is attached is the total voltage divided by the total resistance in this circuit here. So that's equal to our supply of 10 volts divided by 2 ohms. 10 volts divided by 2 ohms, 10 divided by 2 is 5. And because we used volts and we used ohms, we didn't use millivolts or milliohms or anything like that. We've used the standard units. Then the answer will be in the standard unit of amps. So, sorry, that's 5 amps. So the original current equals 5 amps. And now that we've put the voltmeter correctly attached, because there's an internal resistance of the voltmeter, it looks as though we've got this resistor and this resistor in parallel. In series is when they'd be one after the other in a straight line, but parallel is when they are parallel to each other, or next to each other, joined at the top and joined at the bottom. So the equation to find out the new overall resistance, because we need to find the new overall resistance, because we need to know R for a given voltage so that we can find the new current. So we need the new resistance with the voltmeter attached. So the easiest way to find the overall resistance of these two, because basically we can treat these 2 resistors as one resistor if we work out what their mixed resistance is in parallel. And the way to do that is the resistance in total, RT I'll call it, of the 2 resistors is equal to the product of them, which is when you multiply them, divided by their sum, which is when you add them. So the product is 3000 ohms times 2 ohms divided by the sum, 3000 plus 2. So I'll just go over here. The resultant overall resistance of the 2 resistors in parallel is equal to 6000 divided by 3002. And I could do that without a calculator because it's easy to multiply and add these numbers, but working out the actual answer is quite difficult without a calculator. So I'll get the calculator up and I'll do 6,000, which is the product of the two resistors, divided by the sum of the resistors, which is 3002 ohms. And that is 1.998667555. So there's a lot of decimal places. I'd use all of them for now. Use as many as you can for now, just so that we get a more accurate answer. So that's a combined resistance of this resistor and this in parallel. When you combine them, you can treat them as one resistor with this resistance. I'm just going to double check my answer, 1.998667555. So that's the new overall resistance. So to find the new current, we just use Ohm's law again. So the new current, when they're both in the circuit, I is equal to V over R, but now we've got the combined resistance RT, the total resistance, and that's equal to the voltage, which is still 10 volts, divided by the combined resistance, which is that 1.998667555 ohms. So volts divided by ohms will give us a current in amps. So I need to do 10 divided by this number on my calculator. So I'll get the calculator up. All I need to do now, because this answer is already stored in the calculator memory, and press AC, and I can do 10 divided by that answer, and it's equal to this fraction. But if I press the SD button, it gives me the answer as a decimal fraction, 5.003 recurring amps. So it's 5.003, so there'll be threes after that forever, recurring amps. That's the new current with the two resistors combined. So the original current was 5 amps, and now we've got 5.003 recurring amps. So how much has the current changed? Well, it's the difference between these two. The current has increased because when you have resistors in parallel, the overall resistance of two of them in parallel is always less than the smallest one. So overall, the new resistance is less than 2 ohms. So the current goes up when the resistance goes down. So it's changed by 0.003 amps. The change in current is equal to 0.003 recurring, so it'd be 3 forever, but it takes a long time to write something forever, amps. But remember, if that's the units, that's the tenths, there's the hundredths, and there's the thousandths. That's 3,000ths of an amp, which is 3 milliamps. But of course, because it's recurring, we could put 3.3 recurring milliamps. So we'll do more practice on these questions, but that's how you do this type of question. So good luck with this.